So now we come back to our problem of what is the area underneath the function x squared between 0 and 1. And here I've tried to plot that curve to give it a sense of what it looks like. A quarter goes to a 16th, a half goes to 4/16, 3/4 goes to 9/16, and obviously 1 goes to 16/16. And you can see the squaring happening there. 1, 4, 9, 16 are the squares of the first four numbers. We're asking ourselves, what is this area hatched out in red? And to solve that problem, we're going to say that we have a lower limit here of 0 and an upper limit here of 1. And we're going to apply our antiderivative. Now we know now what our antiderivative is going to look like. We have a definite integral. The limits are 0 and 1. And then we're going to apply that to x cubed over 3 plus c. Right. This now represents an area calculated at 0 and an area calculated at 1. And if you want to know what the difference is, we have to subtract 1 from the other. Fortunately, we can see that if we put 0 into this, that's going to be a 0. But we're going to mark the whole thing out anyway. First of all, I'm going to take the upper limit. So we take that limit, we replace the x with that limit, and that's going to give us the area under the curve at 1. Okay. We subtract from that plus c again. C minus c is going to disappear, and we're left that the area under the curve is 1/3 of a square unit, or 1/3 square units. We can see that that is roughly right. We can imagine that there was a straight line there, and if that's a 1 and that's a 1, then that triangle there will be equal to a half. So the fact that this comes to a third really isn't that much of a surprise. Okay, so that's the process you go to calculate the area under a given function between two limits. You have to take the function, find the antiderivative, apply some limits to the antiderivative, and subtract 1 from the other. And it's important that you do that in the correct order, obviously, just like any subtraction. So let's do another function. We'll do another function in the next video, so I'll see you then.